This is something we've done before. That one, Noel, what would we do to break down that 50 right there? Okay, what would work here? Very good. So we got 25 times 2, and what do we get whenever we break that down? Perfect. Okay, we all okay here? We've done that before. All right, so 2 throws a wrench into our problem because we can't take the square root of a negative, right? When we have to deal with the square root of a negative, mathematicians have created a way to deal with the square root of the negative. And that way is by defining the square root of negative 1 as I. Everybody's seen the I before, right? So this helps you get lots of math jokes. Like, for example, up here, whenever you see my banner that says square root of I, love math, or square root of negative 1, love math, that means that I love math. Down here, the one down here that says mathematical insults, it's got this guy right here, and then this guy right here. And he is saying square root of negative 16. What would the square root of negative 16 be? 4i. So he's calling him 4i because he's wearing glasses. If you come across any other good math jokes, print them off and bring them to me. Or email them to me and I'll print them off here. I'll add them to my board back there. Because I love math jokes. They're the greatest. There's some good ones back there. And see, a lot of the math jokes, you gotta be sophisticated to understand them. Like the tan lines problem over there with the girl, and she's got the lines on her back. That's the graph of tangent there. We haven't gotten to that yet, but so you've got to be a little bit advanced to know. So you could know this stuff here. So, knowing square root of negative 1 equals I helps you get lots of math jokes. That might be the only thing that any of you ever benefit from. They tell me that I's are really, really important in a lot of important applications. Now, if you get a job one day where you are using complex numbers to do something with, like create something, build something, you probably have a pretty high-tech job. You probably have something, I always tell students in calculus, if you have a job where you use calculus and you're not a math teacher, you're probably making a lot of money somewhere, because it's high-level stuff that you're talking about here. It's really just a way of dealing with the negatives under the square roots. They tell me that this goes into things like something to do with like networking of cell phone towers. I've heard lots of other applications that I can't remember right now. I took a whole class on complex numbers whenever I was in college, but it was still very analytical. It was not like application of it. It was like, here's how to graph these and do this different stuff with it, but it wasn't really, here's where you apply it. So they can certainly be used. You're going to be getting up to a higher level of that. So some of you may not do anything with these except for get some math jokes now. But they do have their place where they're really important. You'll find at this level, pre-calculus is getting you ready for calculus, and calculus is sort of like the gateway into all kinds of crazy math that can be applied all different ways. And so some of this stuff we're going to do is only applied at much higher levels. But it's kind of cool. So if we had 32, we would just break 32 down like we always would. It would be, the best thing you can use is 16 and 2. And then to deal with that negative, we'll have that -1 right there. Yeah. All right, so the square root of 16 would be 4. We cannot take the square root of the 2. It stays underneath. And then I've got the square root of -1. The square root of -1 I can pull out and make it an I. So basically, anytime you have a negative in that square root, it gets pulled out of the root and made an I, and you break the rest of it down like you always would. So you should have seen this, I think, before in Math 3, hopefully, somewhere. Hopefully. All right, so we got square root of -98. What would we do with that? You might know what will go into that. How can we break it down? 2 and 49, right? So we're going to have 49, 2, and -1. So our square root of the 49 is going to be 7. We cannot take the square root of the 2. It stays underneath. The negative becomes our I on the outside. Terminology-wise, we would call this an imaginary number. Students really hate that whenever I start talking about imaginary numbers because immediately you think we're just making stuff up to torture you with because these are not even real. Why are we worried about them? So these would be called imaginary numbers because they are multiplied by I. When we get on down further, I'll tell you the difference between that and a complex number. All right. Why is this putting squares everywhere? It's possessed. All right, so square root of 125. Reese, how could we break down 125? 25 and 5. So we've got 25, 5, and that -1. So Reese, what are we going to get whenever we simplify that? Very good. 5i root 5. Okay, here. Okay, so this asks us to simplify the expression to a plus bi form. So this a plus bi is what we call a complex number. Okay. The a is just a constant term. It is our real part. It's an actual number. It's 8, it's 7, it's -2. This part is your imaginary part of the number because it's the part that's multiplied by the I. And so together, they form a complex number. Technically, the ones that we were just looking at are going to generally be referred to as imaginary numbers. A complex number has a whole number added or subtracted to a factor that has an I with it. So if we look at this problem, square root of 64 is just 8. We could break down the square root of 48. It would be, is that 16 and 3? So we could break it down and make it 4i times the square root of 3. The square root of 25 is just 5. The square root of 75 here, I could do 25 and 3 times that -1. So for it, I will get 5i square root of 3. So you're just breaking down each piece. Then, pretty clearly, 8 and 5 can be put together and give you 13 there. For these parts, you've got I square root of 3. both the I and the root have to match for you to be able to combine these. So all of that has to be the same. Since they are the same, we can just add the 4 and the 5 and get plus 9I square root of 3. If one of those was like a square root of 2 and the other one was a square root of 3, we just have to leave them separate. We couldn't put those together. Or if one of them had an I and one of them did not, then we couldn't put those together. Okay, questions? Okay. All right, here's our next one. This one throws in a cube root for this one. So, this is really important here. What is the cube root of negative 1? It is negative 1. It is not an I. Okay. Odd roots do not ever have I's. Not sure about, I know that the fourth root of negative 1 can't exist. But I've never had to deal with fourth roots of negative 1. But we're not going to chase that rabbit right now. You won't see a fourth root of a negative number. But if you have odd roots, you can have an answer for that. Because this is saying what times itself 3 times gives me negative 1. Well, negative 1 times negative 1 times negative 1 equals negative 1. So, you can have a root of a negative number. So when I break this one down, the square root of 9 is just 3. So it's going to be on the outside of the root. Square root of 1, I find it somewhat humorous sometimes. I can't tell you the number of smart kids that I have that forget what the square root of 1 is. What is the square root of 1? It is 1. Sometimes I have kids that are in pre-cal or calculus. Sometimes they're even my smartest kids. And they get a square root of 1 in a problem, and they leave square root of 1 the whole time. And then they put question marks, so they don't know what to do because they still have a square root of 1. So watch out for square root of 1 in your worst moments. It might actually cause you confusion. It should be really simple, but it's almost too simple somehow. All right, we got cube root of negative 27. So a cube root is not saying what times itself gives me 27. It's what times itself 3 times gives us 27. So what's the cube root of negative 27? Negative 3. So we're going to have 6 plus 1 minus 3. So 7 minus 3 would just give us 4. So you actually get a whole number for that. Okay, all right, here. Oh, yes, thank you. Yes, this is a 9, which means my answer is wrong. Speaking of those worst moments, 3 times 3 is 9. There we go. All right, here's our next one. So we've got negative square root of 4. That negative's not inside the square root, so it's not going to create an I. It's just going to be negative 2 whenever we take that square root of 4. And then here, the negative's on the inside of the square root, so we're going to get 6I. There's that square root of 1 again. It's going to be 1. And then we got square root of negative 49. That's going to give us 7I. So negative 2, positive 1, that's going to give us a negative 1. 6I and 7I is going to give us 13I. Okay, we good here? Okay, we've got another similar problem. Again, when the negative's on the outside, it's not an I. So this is just negative 4 right here. We'll have minus 3. And what is the cube root of negative 125? It is negative 5. Negative 5 times negative 5 times negative 5 would give us negative 125. So we'll get negative 5 here. This thing is possessed today. I don't know why it's not letting me write. And then we've got negative 25 under the square root. Ronald, what's that going to give us? Yep, 5i. Very good. All right, so we got negative 4 plus 15 plus 5i. And then negative 4 plus 15 is 11 plus 5i. Okay, questions? All right, try the next one on your own. Okay, so answer it here, see if yours matches. Right, yes. So with a cube root, you're going to just have a negative 9, because negative 9 times negative 9 times negative 9 is going to give you negative 729. So you will never have an I if it's a cube root. But very common mistake is to make that an I, because you're so used to doing that with the roots. These numbers are a little bit big. We are going to have a quiz tomorrow. We're going to do that quiz on Delta Math, so I will probably let you use your calculator tomorrow because I can't control how big a numbers Delta Math gives you. This is not totally unreasonable to do without a calculator, but most of you probably don't have the cube root of 729 memorized, and you'd have to do a little fishing for it, so I don't think it'll give you a major advantage for me to let you use your calculator, so we'll probably use it tomorrow. But whenever we're the ones that actually show up on the quiz or a test may be on a calculator inactive section because I may, but I'll give you numbers a little smaller. I might go up to 216. Probably wouldn't do 729 for you there. All right. Okay, let's look at multiplying complex numbers. All right, so if you're multiplying two complex numbers, you can do it a couple different ways. You could break it down first, or, oh gosh, there was one of these that we had trouble with. I think we want to break them down first. Because on Delta Math, Yes, you do. So we want to at least, even if you don't break it all the way down, at least pull the I out. So we'll see one in a minute, I think, where it's going to matter, because I didn't do it that way. So pull the I out. You got square root of 10, I square root of 10 times 6 square root of 90. I'm actually not going to break that square root of 90 down yet. You could do 9 and 10 if you want. And then when you multiply the stuff on the outside together, so you'll get 6i. And then multiply the stuff on the inside together, so you'll get 900. But 900 is a perfect square. What times it's, isn't it? Yes. What times itself will give you 900? 30. So we're going to have 6i times 30. And then so you're just going to get 180 for that. There's a reason why I wanted you to pull the I out first instead of second, and it doesn't matter on this problem whether you do, but there's going to be another one where it does matter. And it is this one, I believe. So, with this one, the correct way to do this is to pull the I's out first. In fact, I don't really want to multiply 84 times 7, because that's a pretty big number. So I'm going to first look for something I could break down 84 into. I know 4 will go into it. Does 16 go into it? No. So I'm going to do this. 8. I'll have square root of negative 1 times 4 times, let's see, that'll be 21. Times 5, square root of negative 7. So I'll get 8 times the square root of 4 is 2. I'm going to have the I from the negative 1. And I'll have square root of 21. And I'll get 5i square root of 7 here. Which is going to give me 16i square root of 21 times 5i square root of 7. So when you multiply this together, you're going to multiply the 16i times the 5i. 16 times 5 is going to give you 90. And then I times I is I squared. 80. Thank you. My multiplication's way off. Yes, 50 plus 30. Okay, and then 21 times 7, at the rate I'm going, I'm just reaching for the calculator on that one. 147. And then I'm pretty sure 49 will go into that. 49 times 3, yes. So 80i squared, it's going to be 49 times 3, so we break it down. And then that's going to give me 560 I squared. Now, I've left the I squared all along. What is I squared? Not quite. It's negative 1. Because I equals the square root of negative 1. And if we square that, the square root of negative 1 squared, the square root and the square would cancel, and it would equal negative 1. So we can replace that I squared with a negative 1, which is going to give me negative 560 square root of 3. I taught this wrong last year, so that's why I had to pause for a second. because if you multiply from the very beginning, so if you do 8 times 5 is 40, and then you do negative 84 times negative 7, you're going to get 40 times 5, 88. That seems like it would be an easier way, especially if you're using your calculator. So 588, let's see, 64 go into that. 588, 144. I think it's actually 14. Yeah, 196. 588 divided by 196. This breaks down into 196 and 3, which is 40 times 14. Root 3. Don't write this down because this is not right. And so that would give you 560. Root 3. But if you do that, the negative disappeared, right? So this is not correct. So you want to put, at least you need to pull the i's out first. Now you do have the option. You could have done 8i root 84 times 5i root 7 and not broken those down first. So you would have gotten 40i root 588 there and could have broken down the 588. I don't like breaking down numbers as big as 588. It's hard to find the number that goes into it, but you could do it that way. But pull the i's out first before you multiply them together. All right, so let's talk about powers of I. We just talked about the first one. So I equals the square root of negative 1. I squared is the square root of negative 1 squared, which just gives you negative 1. What are we going to get if we do I to the third power? That would be I squared times I, right? And what is I squared? Negative 1. So you just get negative I. Let's look at I to the fourth. I could break I to the fourth down into I squared times I squared. Would that be okay? Is it equal? I squared is negative 1. Negative 1 times negative 1 is 1. So I to the fourth is actually just 1. And so if we kept going, I to the fifth, I could break it down into I to the fourth times I. So I would just get I to the fourth is 1. And I would just get I. If I did I to the sixth, I could still use I to the fourth. And then I could do an I squared. So I to the fourth is just 1. I squared is negative 1. I'd get negative 1. If I did I to the seventh, I could do I to the fourth times I to the third, which I to the fourth is just 1. I to the third we've already done. It's negative I. I to the eighth, it could be I to the fourth times I to the fourth, which would be 1 times 1, which is 1. Now, I could keep going, but that same pattern is just going to happen over and over and over and over and over again because we're going from, let me break this I right here. We're going from I to negative 1, negative I, 1. I, negative 1, negative I, 1. All right, and that's going to keep on forever. I, negative 1, negative I, 1. I, negative 1, negative I, 1. So we want to remember that obviously I to the first power just equals I. I to the second power equals negative 1. I to the third power is going to be negative I. And I to the fourth power is going to equal 1. So if we can remember this, so this will be really important for us to have remembered for these problems. If we can remember this, then if I have an exponent that is divisible by 4, right, like I have here, I could just break this down into I to the 4th times 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 I to the 4th. It'd be 8 times 1, 2, 3, 4, 5, 6, 7, 8. I think I've got 8 times there, right? That's just multiplying 1 by itself 8 times, which is just still going to equal 1, right? So if your power is divisible by 4, then you can just know that it's 1, right? If it's not divisible by 4, then choose the number underneath it that's divisible by 4. So if I've got I to the 21st power, the number underneath 21, the next number underneath 21 that is divisible by 4, what would that be? 20. So I'm going to break this down into I to the 20th times I to the 1st power. Anytime your exponent is divisible by 4, you just get 1. So I to the 20th just equals 1. And then you've got I to the 1st power, which is I. So that's just going to give you I right there. Let's see, 58. I don't think that's divisible by 4. It is not. But 14 times 4 is 56. Right? So 14 times 4 is 56. So I'm going to break this down to I to the 56th power times I to the 2nd power. Right? And I just found that out by doing 58 divided by 4. I got 58 divided by 4, I got 14.5. So 14 times 4, I checked, and it was 56. So I to the 56, that just equals 1 because its exponent is divisible by 4. I squared is over here on our list. It's negative 1. So we get negative 1 there. So if you have a problem like this where it's I to a certain power, your answer is either I, negative 1, negative I, or 1. You have to work out which one that would be. Yes? Yes. Yeah. Always check first to see if it's divisible by 4. If your exponent is divisible by 4, then your answer is just going to be 1. If it is not divisible by 4, then you are going to break it down there. And another thing that can help you, like when you're checking this, if you check that exponent 32 divided by 4, you get 8. It's divisible, so it's going to be 1. When you do 21 divided by 4, which these are smaller numbers, so we could do that in our head better. But Delta Math is going to give you some larger numbers here. 21 divided by 4 gave me 5.25. So that means it went 5 whole times evenly, and I had 1 quarter left over, right? So, 5 times 4, we know already is 20. So I to the 20th and I to the 1st, so it just gives us the I to the 1st power. When the bigger numbers come up, 58, if we do 58 divided by 4, we're going to get 14.5. 14.5 tells me we'll go 14 times with 1/2 left over. So 14 times 4 is going to give us 56. So we'll break it into the 56 and 2. You'll also sort of see the pattern. If it's got a 0.25, it's I to the 1st power. If it's got a 0.5, it's going to be negative 1 because that's I squared. If it has a 0.75, that's your I cubed. So that's going to be negative I. And then when you divide it, if it goes evenly, it'll just be 1. Is that Coach Wood? Oh, Coach Wood. We need him to come down here and entertain us for a little bit. Okay, so I to the 29th, I to the 27th, I to the 30th. We could break each one of them down separately, but it is easier what do we do with exponents when we multiply like that? We just add them together. So if we add our 29 plus our 27 plus our 30, 29 plus our 27 plus our 30, we're going to get 86. So I get I to the 86th power. And then, switch back and forth. And then I'm just going to divide it by 4. I'm pretty sure it does not go evenly. It does not. So I got 21 times it goes evenly. 21 times 4 is 84. So you could break this down into I to the 84th times that I squared. And I to the 84th just equals 1 because it's divisible by 4. I squared is negative 1. So we get negative 1. Okay? Let's look at some subtracting complex numbers. Subtracting is pretty simple. Adding is even more simple. I don't know if I even did I put any adding? I didn't even put any adding examples here. So if we were adding, you would do this like the subtracting, but you're not going to have to distribute. So all you do here is you're going to distribute that negative. You basically treat it like the I is an X here. So you got 4 minus 2I minus 4 plus 7I. And then just combine like terms. In this case, I got a 4 and a negative 4, and they cancel. I got a negative 2I and a positive 7I. That's going to give me 5I. You're not multiplying there. You're just adding or subtracting, so don't do I squared. All right, here, same thing. 7 plus 2I plus 3 plus 3I. So if we combine our whole numbers, we'll get 10. And then 5I and 3I is going to give us, 2I and 3I will give us 5I. I could give this to my Math 1 kids right now and they could do it. They don't know anything about I's. They couldn't do any of the rest of it, but they could do this because it's just distributed and simplifying like terms. I'd have to just tell them the I was a variable. They would just assume the I was a variable. They wouldn't look for a deeper meaning there yet, I don't think. All right, multiplying complex numbers, again, is a lot like what you would do if it were just an X. So you're going to distribute just like you would if this was just 2 binomials multiplied together. So my Math 1 kids, this is what we're doing right now. They could probably do this to an extent. They're not going to know the last step. So negative 11 times 2 is negative 22. Negative 11 times 6I would be negative 66I. Negative 7I times 2 is going to be negative 14I. And then negative 7I times 6I would give us negative 42I squared. My Math 1 kids could come up with this. But what they would not know to do is, what does I squared equal? It equals negative 1. So I could combine those middle terms, and I'll get negative 80I. And then I'll get negative 42 times negative 1, which actually when I do negative times the negative, it's going to give me a positive 42 there. So that would be 20 when I combine it with that negative 22. So I'd get 20 minus 80I. All right, we just got a few more questions on that one. All right, let's do another one here. So we would do 10 times negative 8. We'll get negative 80. We'll do 10 times negative 8I to get negative 80I. We got negative 5I times negative 8 is going to give us positive 40. I, and then we'll get positive 40 I squared here. And so we just need to change that I squared to a negative 1. And when we do that, we'll have negative 80. We can put the negative 80I and the 40I together to get negative 40I. This is going to be a minus 40 whenever we change that I squared to a negative 1. And so we would end up with negative 120 minus 40I. I don't know if delta math counts off, but with complex numbers, we always put the real part first and the imaginary part second. Delta math might count it wrong if you type it in backwards. So although mathematically it's equivalent to write negative 40I minus 120, I think they're always going to put the I second. It may or may not count off. I'm not sure. Okay. I feel like we're good here on these. We're going to go ahead and quit so you guys get time to work on your assignment. So on Delta Math today, you are going to have a required assignment, and then I also believe I have given you a practice quiz. Yes. So complex numbers, this is going to be required for you to do today. I've got it set at 18 right now. Hopefully that's a reasonable amount for us to do. We'll see where we're at the end of class if I need to adjust that. And then this is not required, but I have put up a practice quiz. So the practice quiz is like what you'll see on the quiz tomorrow. The practice quiz will have some simplifying radicals that we were doing yesterday, so it'll have that rationalizing denominator, it'll have all of that stuff. It'll also have the complex number stuff that you're doing today. So it's not required, but I would highly suggest doing this, especially if maybe you had a little bit of trouble with this so you can see what you're looking at, because last year students did not do great on this quiz. There should not be any surprises. It's all the same type of problems that you have seen. I'm not going to put anything new. Like, Delta Math, you choose like a category of problem, and you have done all of those categories of problems for me. This is the same thing here. But I would highly suggest looking at this, and if you don't do well on this, come see me in the morning. I should be here for tutoring so that we can look at it, because I want you guys to do well on this and